discussed about the very important rays we have to consider to construct a ray diagram for formation of images in convex and convex lens. Today we shall study about image formation in convex lens. Okay. So here what we are going to do, we are going to place the object, a very small linear object is taken like a lighted candle. Okay. Linear object means a straight object, especially we prefer candle light because it is very easy to obtain the image and the image can be seen very clearly on the screen. So we will use a very small linear object and we will place the linear object in front of the convex lens at various positions and try to get the images. Okay. After getting the images, what we will do? We will start studying about the characteristics of these images. Understood? So here I have taken some 4 cases where I have placed the object, linear object. So the first case is object at infinity. Here I have not shown the object for it because the light rays are coming from the object which is at infinity. In my previous video I have told you that whenever you want to construct ray diagrams, you have to mark some of the points. See, this is the principal axis of the lens. This will be the optic center. This is the first focal point, second focal point, and this will be center of curvature of the lens. I have named it as 2f1 and 2f2. So here, after marking all these points, we shall consider rays coming from the infinite object. Okay. So the rays must be considered parallel to principal axis because the object is at infinity. Remember, whenever the object is at infinity, we have to consider the light rays which are coming from the object as parallel only. So the parallel rays are coming from the object, and after refraction, how they are passing through? They are passing through the principal focus. So I have considered 2 rays, one above the principal axis and one below the principal axis. After refraction, how they are passing? They are passing through the second focal point of the convex lens, and here the image will be formed. So at f2 image will be formed. Image will be formed at f2. Okay. And what will be the nature of image? It is highly diminished, means very small in size, highly diminished, inverted, and it will be real. So this is the position of the image. Image will be formed at the f2. And what are the characteristics of this image? It will be highly diminished, means very small in size, about point size we will get the object. It will be inverted and it will be a real image. So this is the concerned ray diagram for the formation of image when the object is at infinity. Next, coming to the second case, object beyond 2f1. So here you can observe, again I have considered the linear object here. I have named it as AB. Object always show it a straight line with an arrow mark. Understood? So it will be easy to identify in ray diagram. Now, as I have told you in my previous video, some 3 rays we have to consider. One ray which is passing through the optic center, another ray coming from the object and incident on the principal focus, and the third ray is a ray parallel to the principal axis of the lens. But among those 2 rays, 2 rays are enough for us to complete any ray diagram. Which are those 2 rays? A ray which is parallel to the principal axis of the lens and the ray which is passing through optic center of the lens. Okay. So here I have considered and I have shown it in different colors also to distinguish between the 2 rays. So this is one ray which is parallel to the principal axis. After refraction, according to the rules, which has to pass through the second focal point of the lens, right? And the one more way is the ray which is passing through the optic center of the lens. So it goes undeviated, and you can observe that the image is formed in between f2 and 2f2. Is it not? When you compare the size of the object and the image is smaller in size. So where is the image formed? The image is formed at image is formed between 2f2 and f2. F2 and 2F2 image will be formed. And what will be the characteristics of this image? It is real, right, inverted and diminished. Real, inverted and diminished. Okay, so this is the second case in case of convex lens. Now coming to the third case, the object should be considered at 2F1. Here again I have considered the linear object AB at 2F1. Again consider two rays. I have shown in blue and pink colors to distinguish between the two rays. So these light rays after refraction where they are meeting, see they are meeting at 2F2. So where will be the image formed? Image will be formed at 2F2. What is the characteristics of the image? It is real, inverted and object and image if you consider it will be of the same size. So same size of the object. The size of the image will be same as that of the object. Okay. So this is the third case. Now coming to fourth case, object between 2F1 and F1. Now here again linear object I have considered two rays. One ray is parallel to principal axis, another ray passing through the optic center. See where they are meeting? They are meeting beyond 2F2. Is it not? Beyond 2F2 they are meeting, and you can observe that the image is enlarged as compared to the object. So where the image will be formed? The image will be formed beyond 2F2. And what are the characteristics of the image? It is real, inverted and enlarged. Or you can write magnified also. Real, inverted, enlarged or magnified. Okay. So next case we shall consider fifth case. All these ray diagrams have been given in the textbook, and a table is also printed which lists out the position of the image, position of the object and various characteristics of the image. All that table you have to go through. Okay. Fifth case, object at F1. Again, consider the convex lens. Okay, as I have told you, you have to mark optic center, then focal points 2F1, 2F2, right? Consider the linear object. Now, how many rays you should draw? One ray which is parallel to principal axis. After refraction, it must pass through principal focus only. Okay. Another ray, how we have to consider? The ray which is passing through the optic center, it goes until the end. See. Like this, you will get the rays. Now, in this case, you can observe that these two rays are running parallel and they will meet at infinity. Meet at infinity. Okay. Now, where will be the object formed? Object will be where will be the image formed? Image will be formed at infinity. Image will be formed at infinity. Of course, you can see the image very blurred. The image will not be clear in this case. And what will be the characteristics of the image? The image will be real, inverted, okay, and highly magnified. Highly magnified. Okay. So this is a very important case in case of convex lens when the object is at 2F1. Two rays you have to consider. These two rays after refraction they will not meet at any point. They will meet at infinity. At infinity image will be formed. But when you try to catch the image on the screen, the image will be highly magnified, but it will not be clear. It will be blurred, but it will be real and inverted. Okay, this is the fifth case in case of convex lens. Now coming to the last case, that is object between F1 and optic center. Means first principal, focus and optic center. So again consider the convex lens, mark all the points. Okay, 2 F1 and also to F2. Now where we have to place the object, linear object must be placed in between F1 and O. Now two rays you have to consider. See here, one ray which is parallel to principal axis after refraction, it must pass through the principal focus. Another ray, how we have to consider, passing through the optic center of the lens. Now, here you can observe that these two rays after refraction, they are getting diverged, is it not? So, they are getting diverged after refraction. To obtain the image, what you have to do is, you have to extend these two rays backwards. So, I am extending the two rays backwards. And these two rays, when extended backwards, they will meet at a point, and there the image will be formed. Where the image will be formed. So here, in this case of convex lens, when you place the object between F1 and O, that is principal focus and optic center of the lens, the refracted rays will diverge. What you have to do, you have to produce both the rays backwards till they meet. There the image will be formed, and that image must be shown with the dotted line, because the image formed is a virtual image in this case. So what are the characteristics of this image? The characteristics of this image is virtual, and it will be erect. Erect, as I have told you in my previous videos, it is upright, virtual, erect, and magnified. These are the characteristics of the image formed. So in your textbook you can just refer the various ray diagrams which are given, and at the end of this unit even a table is printed in the textbook which lists out the characteristics of all the images formed in case of convex lens along with their applications, means where a particular setup of lens is used. Like if you consider the last case, object between F1 and O, this type of lens is used in a simple microscope. Okay, because we are using convex lenses in telescopes, in camera, in microscopes, different type of setups are used in different optical devices to get the images. Okay children, so these are the concerned ray diagrams which you have to learn. I shall continue in the next video.